I don't want to change anything. Again, that they will ask so many answers. For me, it is comfortable. ఆఫ్లో ఉంది.
A very good afternoon to one and all. Respected director, distinguished scientist, invited guests, and my dear colleagues. On behalf of CSIR 4PI, it gives me immense pleasure to welcome you all to the Curtain Raiser event of India International Science Festival 2025. Today's gathering marks the beginning of a national celebration of science, innovation, and technology, a festival that brings together researchers, educators, and entrepreneurs and young minds from across the country. We are honored to host this prestigious curtain raiser at CSIR 4PI. At the outset, I would request our director, Dr. Gopalakrishna Patra, to kindly accompany our chief guest, Professor Vivekananda Pai, to the dais. And I also request Dr. Imtiaz Ahmad Parvez, Chief Scientist and at IDRD and TMD, Dr. V. Rakesh, Senior Principal Scientist, to join along to the dais. To symbolize knowledge, wisdom, and spirit of scientific enlightenment, we will now proceed with the lighting of the lamp. I request our esteemed dignitaries to please come forward for the ceremonial lighting. Thank you to all the dignitaries. Let this light guide today's event with clarity and inspiration. I now invite Mr. Ratindra Gaur to lead us in the invocation.
श्रीनाथे जानकीनाथे अभेद परमात्मनि तथापि मम सर्वस्वः रामः कमललोचनः ॐ श्रीरामचन्द्राय नमः। वर्णानामर्थसङ्घानां रसानां छन्दसामपि मङ्गलानां च कर्तारौ वन्दे वाणी विनायकौ। भवानी शङ्करौ वन्दे श्रद्धा विश्वासरूपिणौ याभ्यां विना न पश्यन्ते सिद्धा स्वान्तस्थमीश्वरं वन्दे बोधमयं नित्यं गुरुं शङ्कररूपिणं यमाश्रितो हि वक्रोऽपि चन्द्रः सर्वत्र वन्द्यते।
Thank you, Mr. Ratindra. I now invite Dr. Imtiaz Ahmad Parvez, Chief Scientist and at IDRD and TMD, to deliver the welcome address and introduce our chief guest.
Good afternoon. I hope all of you are awake after lunch. This is difficult. We were scheduled to come here in the morning, but due to the flight delay of our chief guest, we had to postpone in the afternoon. Dr. G.K. Patra, our director, CSIR 4PI, Shri Vivekananda Pai ji, who is a Secretary General, Vijnana Bharati, and today's chief guest of this curtain raiser event. Dr. Rakesh, Senior Principal Scientist, who is giving a popular lecture today on this occasion. Distinguished members of the dais, colleagues, students, all other staff of 4PI, and all the guests who are participating online. Very warm welcome on behalf of CSIR Fourth Paradigm Institute and on my personal behalf on this 11th India International Science Festival 2025 Curtain Raiser event that we are celebrating today at 4 p.m. Of course, we have a distinguished chief guest who will be, I think, speaking more about IISF, but because I have to welcome, I just briefly tell what is IISF. So the India International Science Festival is an annual nationwide science celebration and that aims to promote scientific temper among the masses, showcase India's achievements in science and technology, and inspire young minds to pursue careers in science and technology. It is an initiative of the Ministry of Science and Technology and the Ministry of Earth Sciences of the Government of India in association with Vijnana Bharati, which is a science movement with Swadeshi spirit led by many eminent scientists of the country. Since its inception in 2015, the IISF has evolved into India's largest science outreach platform, an annual celebration that bridges the gap between our laboratories and society, ensuring that the joy of doing science is experienced by all. Under the visionary leadership of our Honorable Prime Minister Shri Narendra Modi ji, Honorable Minister of Science and Technology Dr. Jitendra Singh ji, the science and technology have become center to our national policies and governance, steering India towards becoming a global science powerhouse and achieving the vision of a developed India by 2047, when we celebrate 100 years of our independence. This year, IISF 2025, the 4-day festival, is running from December 6th to 9th, is more than just a gathering. It is a convergence of minds and ministries, an ecosystem of innovation designed to showcase India's expanding scientific capabilities and foster a spirit of self-reliance. IISF 2025 is dedicated to celebrate the power of science, technology and innovation, united by our inspiring theme that is Vigyan Se Samriddhi for Atmanirbhar Bharat. So to organize this curtain raiser event of IISF 2025, we are really delighted that we have with us today Shri Vivekananda Pai ji as a chief guest, and he is currently Secretary General Vijnana Bharati and Vice Chairman of National Innovation Foundation. I have to introduce to the audience to the chief guest, but before I introduce, I request our director, Dr. G.K. Patra, to please welcome our chief guest with a plant. Thank you. It's really a privilege for me to introduce our chief guest to the audience. He is architect by profession with nearly 27 years of experience. And as I said, he is the Secretary General Vijnana Bharati, the largest voluntary platform of scientists and technocrats in the country since June 2024. Presently, he is also the Vice Chairman of the National Innovation Foundation, an autonomous institution of DST, Government of India. He also writes occasionally on the popular science magazine Science India. Shri Pai has been active in Swadeshi science movement, the Kerala chapter of Vijnana Bharati, since 2005. He has been involved with Shastra Pratibha Matsaram, presently Vidyarthi Vigyan Manthan, during its inception. He has been part of activities like Swasarya Bharat, the National Self-Reliance Week, celebrations in various capacities. He has been the coordinator for Suraksha 2013, a national defense expo with extensive participation from DRDO, Indian Navy, ISRO, and many other industrial units. The event also included panel discussions and interactions of various segments. As general convener of the first World Ocean Science Congress at Kochi, he was part of the team that visualized the event as well as brought together various segments related to blue economy and national security. The event saw participation from around 80 nationals and 14 international organizations. The shipbuilding roundtable as part of WOSC 2015 was unique due to the participation from shipbuilders, owners, regulators, financial institutions, and ancillary industries. As a secretary of Rashtriya Urja Jan Jagriti Abhiyan, a campaign for an orange revolution in the area of energy security of the country, he was part of the team that conceived and implemented the idea of Urja Yatra in 2011 across the country, covering almost 8,000 kilometers, propagating the message of renewable energy. He is also part of the team of Vibha that is working on sustainable habitats. At a policy level, he has also been involved with the formulation of Vibha's approaches on environment, agriculture, education, and development. Thank you so much, sir, for accepting our invitation and gracing the occasion. And with this, I welcome you all once again to this science festival and enjoy the lecture by Dr. Rakesh and continue with the forum. Thank you. Jai Hind.
Thank you, sir, for that brief introduction of our chief guest. Now we will play a small video on Science Festival.
Under the visionary leadership of Honorable Prime Minister Shri Narendra Modi ji, India is fostering scientific excellence and remarkable innovation. In line with the vision of Atmanirbhar Bharat,
आजादी के 100 साल हम ऐसे ही नहीं बिताएंगे। आजादी के 100 साल ऐसे मनाएंगे कि दुनिया में विकसित भारत का झंडा फहरता होगा।
setting a similar tone, India International Science Festival (IISF) began its journey in Delhi, 2015. 10 editions of IISF have been organized in various parts of the country. Today, it has grown into India's largest platform, celebrating science, technology, and innovation, bringing together scientific stakeholders on one stage. The India International Science Festival IISF 2025, with its theme Vigyan Se Samrodhi for Atmanirbhar Bharat, will celebrate the spirit of innovation and Atmanirbharta in India for global good. The festival will be hosted at Punjab University, Chandigarh. Will feature vibrant thematic events that highlight India's achievements, innovations, and advancements across diverse scientific fields. The festival's core agenda is to strengthen the partnership between industry, academia, private innovators, and government, fostering collaboration and driving the nation's scientific ecosystem forward. The future, the Viksit Bharat 2047, starts now with the India International Science Festival 2025.
We now move on to an engaging and insightful session. I invite Dr. V. Rakesh, Senior Principal Scientist, to deliver a popular talk on smart agricultural technologies for soil and plant health.
Good afternoon. So today I will deliver a talk. Basically, it's based on the work we carried out as part of the mission project, which started 2 years back. Now we are in the final year of the project. So this project started around 2 years back, and actually, as you see from the slide, it is like 9 CSR labs involved in this project, and the project is formulated in such a way that it is multidisciplinary in nature. That means like expertise of 9 CSR labs. Expertise of 9 CSR labs are like used while like formulating and implementing this project. So here CSR 4P is the nodal lab. So here we will be like mostly like carrying out the work like predictive image analytics, model development, and dynamical crop modeling, all these aspects. The other participating lab, like there are engineering labs, they mostly like support us and contribute to the project in agro-technologies and help us. And some of the agriculture lab, they help us in conducting field experiments and field data collection. And apart from this CSR Institute, 3 universities, agriculture universities, like in Karnataka, US Bangalore is as part of an MOU. They are also collaborating in this project. And from Tamil Nadu Agriculture University is part of this project. From Kerala Agriculture University is part of this project. So today I will be like discussing how this science and technology is, through science and technologies, how we can monitor and manage soil and plant health. So I will start with soil, then I will move to the plant. And I have arranged the slides in such a way that like it's component wise. If the time permit, I will complete everything. Otherwise, you can give me a signal. So we all know that see, we are like many nowadays, many article or many like literatures you may have like studied or read that about precision agriculture, because now we are in a stage, countries in a stage where like the agriculture productivity is almost saturated. So now we cannot afford to like waste our resources, and other aspect is that we now the incremental change only we can expect from in the agriculture productivity point of view. So in that aspect, precision agriculture is very important. So the mantra of precision agriculture is based on 3 R's. It's right input,
First, you back, you will
Prakash. It's based on the principle is based on 3 R's. It's like right input at right time at right location, whether it is fertilizer or whether it is pesticide for like disease management. So in my presentation and in this project, actually we are like touching the different, like we are basically like touching the different aspects of precision agriculture. One is soil health management through like smart agro technologies, and crop health monitoring and management. So through like technology applications, then crop management, then crop yield monitoring, and then IoT based microclimate observations, that's again for disease monitoring. And then actually these IoTs, as part of this project, we are developing indigenous data loggers and sensors, our partnering lab. So they are like developing the sensor part, and we are implementing the IoT in the field. And our another collaborative partners is CSR lab, CIRI. They are developing a controlled environment agriculture system where you can do the high value crop cultivation with the support of IoT networks and automatic resource control. So now why like, so first I was saying that in my talk, first I will cover the soil management part. So here like why soil management is very important, because for the crop, like once you are like sowed or transplanted, so most of the nutrient comes from the soil. So the crop yield or the final productivity is very much dependent on the soil health. So what are the like techniques? So coming to the precision agriculture perspective. So what are the the latest technology which is of the state of the art is digital soil mapping. And now why digital soil mapping? Because the currently the normal practice followed in country like India is we apply fertilizer in a uniform rate. Suppose we have marginal farmers, they most of them are 1 to 2 acre, maybe 1 or 2 hectare in maximum, larger farm field. So what they do is that there is a recommendation from the university for a hectare, suppose it is 40 kg of urea. So what they do is that the recommendation is 50, 25, 25. So during the basal stage, that means soil preparation, they do 20 kg, then 10 kg, 10 kg. So but what they do is that this 20 kg they apply uniformly across the field. But in practical, so our we analyze, I will show some result. So in reality, the soil nutrient availability is not uniform across the field. So our I will show some result. So since the nutrient distribution is not uniform, so the uniform application strategy is not a wise strategy, because if we do uniform application, it can either lead to excess nutrient or deficit nutrient. So both are dangerous, because excess nutrient, it can lead to make the soil toxic, it can spoil the soil health, and it will lead to wastage of fertilizer, and also eventually it will lead to the loss of farmer income, and it is hazard to the environment also. On the other hand, the deficit application result in malnutrition of the crop. So it will again affect the yield, and it will result in loss of farmer income. So what is the state of the requirement is? So you go for a precision agriculture practices, where we are developing a methodology through which you can do a fertilizer application in the crop field in a variable rate. That means the right amount of fertilizer at right location. Suppose there is a portion in the crop paddy field or any crop field where the nutrient is adequate, our methodology says you no need to apply fertilizer. So I will explain how it is done in my coming slide. So this is the first part of the project of our study. So we are developing a variable rate fertilizer applicator based on the digital soil mapping. So for this project, we have taken around 12 farmer paddy field. So not only paddy field, there are other four more crops are there. So here I am presenting the result, result from the paddy field. So this is distributed across the India, because we selected the field such a way that it represents different agroclimatic zones in the country. Because this practice, farm practices, soil conditions are different in these different locations. So we have field from Kerala, Tamil Nadu, Karnataka, and Punjab, and Himachal Pradesh, UP, and Kashmir. So what we do here is that we use a technology which is based on the proximal soil sensing, which is works on the principle of gamma ray spectroscopy. So that means we quantify the gamma ray emission from the soil using a device called soil optics. So it is mounted on a tractor. So after mounting it on a tractor, so we run the tractor. During its run in the crop field, so it scans the field. So in a half an hour time, it can scan around 2 acre. And because we CMERA have developed a handheld device also to mount this optics machine, because in Palambur and all the field is so not uneven, it's only hilly terrain, so the tractor cannot run there. So in those places we develop they designed a hand pulley so that we can mount the device on that. So when the nutrient is mapped, the next part is analyzing the data. So based on the nutrient map, so we need to develop some kind of applicator map. That means in a paddy, for example, in a paddy field, we should have grid-wise. We should make a grid-wise map, geotagged map. So that will tell like that for each grid how much gram of fertilizer need to be applied. So that is what like in CSR 4PI we does that part. And so we like after our first experiment we came to know that of course our sensing instruments have some kind of bias and error. So with our like the now I think we have around almost the third year and around 6 season data is there. So using that data we developed we use the machine learning algorithms to improve the sensed estimate. I will show some result. So once the improved sensed estimates are there, so we developed a new methodology for developing the variable rate applicator map. So this is the example I was saying that like, see this is the Nagarkot paddy field. So you can see that it is actually 0.7 acre land, like 70 cent basically. So you can see that how the nutrient is spatially varying here, like all the nutrient basic, macro, micro, all the nutrient have huge spatial variability. This is the actual what is observed. Like here the shaded one is the sensed by the device, and whatever you are seeing the values like digital values are lab analysis, ground truth. So we collect sample at every 5 meter from the field. We bring here, we send to the laboratory and analyze. So that initially that exercise is done for validating the soil optics. And the right one is the Ludhiana field. The story is same. There also you see lot of spatial variability. So basically this like tells that the uniform application strategy is not a like it's a good strategy or like it's not a suggested strategy. So you need to go for a variable rate application. So now after like I was telling that, so initially like after few of our experiments we found that so there is a like error in the model when we compared with the ground truth, like laboratory analysis, like the sensed estimate. So we used machine learning models, see 3 popular machine learning models. So what you see in the bracket like green is the original sensed estimate, error in the original sensed estimate, and we used the machine learning model. So after with the machine learning model we could reduce the error in the estimation significantly, and this is more clear here. If you see, the top one is the lab analyzed and the middle one is from the like soil optics, basically proximally sensed one, and the bottom one is the improved with the machine learning method. So you can see that pattern. If you see this, so you can see that it is like because the original one was not picking the like the variation like in the ground truth, but after the machine learning application, so the variability is better depicted. So now I was saying that once the map is ready, like we got the estimate, the next challenge is like making a map like this. So we like the current methodology, like usually agriculture, like in the agriculture practices is followed is based on the STCR. It is like soil test crop response. Actually it is like it is too much like experimental data dependency, because in the sense that like you need to conduct a lot number of experiments for a particular soil, particular crop, and for a particular like season wise also, like because for management practice wise also. So because that is not practical in reality, because when you want to make a methodology which you want to scale up for a larger scale, for a like a cost effective way, so that is not practical. So we now like come with a new methodology. So now this like we are trying to publish in a very high impact journal. So based on this new methodology, so that here the dependency is only on the dependency is only on the available nutrient, and there is one parameter called nutrient intake efficiency. So that actually there are thumb rules for that, like basically for example nitrogen it is 0.5, for phosphorus it is 0.25, like that. So that is that doesn't vary that much with the soil. So based on this new methodology, so we have like generated this kind of variable rate applicator map. So here we can see this is the potash, maybe like here of like potash, that is for the potassium deficiency. So it is the potash in gram need to be applied in every 3.5 meter square grid in the paddy field. Fine. So if you see this map, you can see that it varies from like something like around 30 to like 130 or 140. That means like the application requirement is not uniform. So if we don't follow this, like we were checking that, suppose that when the total available like potassium or potash required was like, suppose average was coming around 80 or 90. So we will be putting the 90 gram of potash across the field. So it comes to a larger amount of fertilizer requirement compared to this. So in that way we will be saving lot of fertilizer also.
Sir, I have one question.
Yes.
Like this analysis, what you have made
Yes.
on the database, so your studies depend on a particular kind of soil now
Yes.
and particular region.
Yes.
So it cannot be standardized and used in some other part of the
So that's why we have selected field in such a way that across the India we have selected
So
field.
one indicator could be given which is applicable to all.
No, that's why this map will be generated for different field. So that's what I am saying. That is for Nagarkoil and this is for Hospital. So this map will be generated.
That means that many studies are required. How many type of soil?
See,
how
like
many-
suppose like madam, you are from Lucknow, right?
Yes.
Yeah, suppose you like you wanted to apply this technology in Lucknow. So like we will be like coming with the soil optics. We will be like doing a 20 or 30 acre field in Lucknow, and when like we will be collecting some reference sample. So then we will be getting this map. Then we will be developing, based on the map, we will be developing using the new method. We will be developing this nutrient map. Now this till here it is science part of it. Now we need to apply this in the real field. That is the real challenge. That is the engineering part of it. So that is where like so yeah, actually once we get the map, what we does is that for last two seasons we have given generated advisory based on this map to the farmer. Like whoever the farmer, as part of the project we are giving advisory. So for example like Kottayam, actually you may be knowing that actually Kottayam is wetland cultivation. So there like the soil is so acidic, like it is nitrogen is surplus. So actually there no need of like applying urea. But farmer was, because of the practice, he was keep on applying the urea. But last season that our farmer Jalil, he didn't apply urea. Usually he applied three stages, but like he applied only one stage with a less amount. But in the end, like he even like given a like feedback that there was no difference in the yield. So basically like he was like because of the standard recommendation, he was simply putting the unwanted urea. So similarly like we have given SOP for that hospital farmer, and this is for the SOP given to the apple farmer in Kashmir. So like similarly like in Nagarkoil, I remember like last time, because like they used to do the soil like preparation based on the TNAU recommendation, because they are a partner to us, like our partner. So like so they used to like follow their recommendation. But this time, because we told that there is a large boron deficiency there, so like because like then they even consulted the TNAU, so they also agreed after our results. So this time like the farmer like added that boron added extra fertilizer to manage the deficiency in boron. So I was saying that now see that map is ready, but the real challenge is how we will put, because for a human it is not practically impossible. It's practically impossible to do a variable rate fertilizer application. So how to overcome that challenge? Two engineering labs shake hand with us. So one is CSR NIL. So they were developing a UAV based variable rate application methodology, and CMERI lab is basically developing a ground based applicator. So you can see that once this map is there, like geotagged grid map is there, so this ground applicator have a control unit. So that control unit will automatically read this geotagged fertilizer value, and accordingly you will see that there is a chamber. So the chamber have 3 valves. So one like and 3 like it has 3 compartments. One is for nitrogen, one is for potassium, one is for phosphorus. Like that means NPK you can do at a stretch. So you put the amount of like required in this each chamber. Then according to the grid value, like the requirement, the nozzle flow rate and nozzle width will be adjusted in this. So you will be seeing the nozzles here. So this nozzle will be nozzle width as well as the flow rate will be adjusted as per the data given like read by the control unit. So accordingly, like so we are like we will be dispensing the fertilizer in the right amount at right location at right time. So similarly, like a similar controller is like on board, because why we need UAV? Because once the crop is grown, like because this may be okay for like during the basal stage, that means soil preparation time, but once the crop is grown you cannot run a tractor. So that's why like so that time you need a UAV based applicator. So NIL is developing that. So this left side is the ground based applicator and the right side is that NIL like. So both the applicator prototype is ready. We are doing lab testing, and the aerial sprayer, UAV based sprayer, we did one trial, field trial in Mandya, but it was not successful because we could like control the volume like amount, but we couldn't like still couldn't get a success in the dispensing the fertilizer uniformly across the 3.5 meter square grid. So that still we are working on that. So you can see that this is the like applicator, like ground based applicator CME array is developing. The entire system is indigenous. They are developing it, including the control pan, collecting pan, and sensor, everything. You can see that they have a test bed also. So they like before implementing in the field, so they are like checking that. So for example, these are like our grid, identical to our field grid. So this like they are checking that the exact amount is falling in these grids, like before like checking this in the real farmer field. So coming to the, so that soil health part is over. So actually now the current stage what we are in like that, both the applicator prototype is ready, rigorous lab test is going on. Still we are like, you can say like not fully like confident to take it to field. So that the trial is still going on. Coming to the next part. So now soil management is done. Now coming to the crop management, how we can manage the crop. So the best way is that, see earlier days like we used to like, it was mostly like manual because these kind of technologies were not available. So like farmer used to like their own like experience knowledge, they used to physically go and inspect the field and take a management decision. Because now we have the remote sensing, so it is very useful in the sense that it is cost effective. You can cover a large area, and yeah. But suppose like if it is like earlier, like people used to go like, but suppose even like we use the instrument to validate the remote sensing based methodology, but that in a long run, you for scale up, like you need to go for a technology which is aerial or like a large scale. So remote sensing data, like mainly this satellite data, satellite based remote sensing. So there also like we have a lot of satellites. So that is the plus point if that, and it is more suitable for larger area monitoring, and it is cost effective because already satellite is there. You need to spend money on that. But now the question is that whether like satellite data is enough for all type of application. So my answer is no, because like certain type of application, satellite data resolution is not sufficient. I will show in the coming slide. So that is where the UAV can play a role. So I like see there are different type of camera you can fit in the UAV, that UAV or like drone, basically it's a common name drone. So you put these cameras in the drone like multispectral, hyperspectral and radar. So hyperspectral can give a spectral, it can like give the spectral data in the range of 400 to 1000 nanometer, and maybe like depends on the camera, like the spectral bands varies from like 300 to 400, 300 to 400, and the hyperspectral camera what we use is of 7 spectral band, and the lidar camera, that is basically for that like estimating the terrain height as well as plant height and estimating the biomass. So I will tell like why we need a UAV, like see, because nowadays satellite data is of very high resolution, because Sentinel and all giving 10 meter resolution, but certain applications still we need UAV data. I will tell why it is from the slide. So this is the philosophy we follow. So here you can see that for validating our aerial remote sensing data, we collect very high resolution in situ data during our field campaign. This is we have put marked poles in the field every 5 meter apart. So you can see these points. These are the field data point collections. So once this ground truth is there, so we are validating with the UAV derived phenology as well as satellite derived phenology. We are validating with the ground truth. So and why we are the advantage is that this phenology is very helpful in making them up like this stress mark. That also I will explain how to do that. And similarly deriving the vegetation indices. So those indices are indicative of the crop health and whether future the possible crop yield. So this is how the indices are generated. So it is from UAV or narco field. You can see that. So the ground resolution is 4.4 millimeter resolution. So you can millimeter resolution. So UAV is flown at 10 meter height. So I understood that you are saying, yeah, it's true. Because why it is 4.1 millimeter? Why we need that also I will explain. Why we require that. So this is how these different indices we can derive. So these are indicative of crop health. Suppose a healthy crop, the indices from these indices values, we can identify that crop is healthy or not. So now this is a comparison of satellite versus UAV. So this, if you see this graph, this clearly tells the story why we need UAV. Because here this shaded region is UAV in the left side. These are two most prominent vegetation indices, NDVI and LI. And whatever the values shown in as values in the figure is ground truth. So the right side you can see that the satellite data hardly give the signature of these indices. So the values are very less, it is not showing the variability. So this is for the Kottayam field. Story is same. We checked for different field, Nagarcoil, Hospete, Jammu and Kashmir. So irrespective of the place, story is same. So this is the summary slide. You can see that somebody is this is the average statistics, how this data distribution is very clear. You can see that the ground and UAV have more or less similar pattern, but the satellite data differs very significantly because the entire pattern, because I think they are there is some kind of there may be tuning or something, the values are not showing much variability. So this even we checked for the temporal case also, we compared this different satellite data with in situ data and UAV data. The story is again the same. The ground truth and UAV is very closer. So we used dynamic crop model for the simulating the crop growth. That means the rate at which crop growth during the, suppose it is a 3-month or 4-month crop. So we start from here. This is the end period. This is the rate at which paddy crop grows in the field. So you can see these are different type of experiment we conducted, because this simulation is from the weather data, weather station data we have put in the field. So you can see that the major phenological stages are clearly depicted in the model. So these models have some limitation. These are the standard state-of-the-art model APSIM and DSAT used by the agriculture community. But this model, the limitation is that this model cannot do spatially simulate the crop phenology. So that's why we use the WRF crop model. So we coupled a crop model with the WRF. So initially we did a first simulation because with the default data set, so that is USGS data set, but we couldn't get the desired result. So that's why we changed the USGS data set from using the satellite data, high resolution satellite data set. So the model initial, after changing the model initial condition, so we are seeing that so this is the default simulation, the original simulation with the default data set come with the WRF. So this is the data set we derived, the initial condition we derived from the sentinel satellite, and you can see the difference in simulation. So the phenology patterns are now clearly visible in the improved simulation. So this advantage of this model is that we can do it for a larger area. And now the resolution with which we are running this model is 300 meter. So that means like for a district we can give a kind of advisory based on this type of model. So this is how machine learning models can be used for predicting the leaf area index. So from the observed field sample and the satellite data, UAV data. So we have developed used the different type of model architecture. So we are seeing that some value like 1.12 lakh. That is basically 1.12 lakh simulations for each model. So here you are seeing 4.48 because here we have used 4 variant of LSTM. So that's why together it is 4.48 lakh. So from this all combinations of the model simulation, we select the best guide for the final validation purpose. So we could we found that the bidirectional LSTM model is the best one, and we could get some very high accuracy. So that means this machine learning methods proved to be promising technique for this. So this is for the chlorophyll estimation. Again, we have used the machine learning models. So initially we have done without the data augmentation because of the less number of data set, the accuracy was relatively less. But with the data augmentation, the accuracy is quite improved. You can see that among the model, STRAT is giving the best estimation. So here the estimated the test data we validated with the SPAT, that chlorophyll estimated from the SPAT in situ observation. So this is the phenology estimation from SAR data, synthetic aperture data. Sentinel-1 have a C-band synthetic aperture radar. So this is again the estimation of NDVI and LI from the SAR data. You can see that there is a very good fit, the machine learning estimated this thing. And this is we used sharp explainer. This analysis is conducted to see that actually which dependent variable is contributing maximum to the positive or negative prediction. So now till now it was more kind of so this is the demonstration how we can use this remote sensing technology and in combination with the AML technology, how we can do the crop monitoring and management. So I will stop here because I don't think it will be overdose. I have some 2-3 also 3 components, but for time being I will
First slides of each one.
maybe I will go to the summary thing. Yeah, this is, so this I was saying that yeah. So we were preparing a soil grid map. So similarly, this is a stress map, the crop stress map. So this is here the high value of red indicates crop is stressed in that region. So advantage of this map is that now farmer no need to apply fertilizer wherever this green is there. So he need to apply fertilizer only this red portion. So basically the uniform pesticide application is also gone. So next is, so this is a methodology for deriving this map, and yeah, this is this is again based on the machine learning deep learning technique. So how we can develop crop stress model. Suppose you finally the ultimate objective is the ultimate objective is to come with an application like this, which can be loaded on a mobile or a workstation. So it can you give an image, so it will tell that okay, what type of disease it is, whether it in paddy case, whether blight, blast or something. So this is the entire process. You can see that we collect data set from the UAV, process the data, make a stress map for labeling it. Then, so actually we developed an in-house application, mobile application to collect data, because initially we were facing problem in data consistency because different people taking photos, basically it has a manual error. So avoid that. So Mithun have developed a in-house application for collecting the data. So this now we are using this application, and the data set which are collecting as part of this, we are collecting this, we are planning to put an IP copyright. even that applicator of soil health one, so there is a like here, the entire methodology we are planning to patent it. Here we are planning for an IP copyright.
Here you are reducing this age or it is like automatically?
Actually, for like we see initially we used to collect data from the farmer field. Because we are not getting sufficient data, now in the Mandya research field, university field, so we have put susceptible variety. There like disease is very prominent because the farmer field, so the moment disease symptom is that they will put pesticide and you won't get enough sample. So that's why like the research field, we are doing the regular experiment to collect more number of data set. So this is the IoT network we are putting in. This is first of this kind. Actually, in the typically like the crop model, and generally they use data at 2-meter height, the AWS data. Actually, what it matters for the crop is what is the temperature, humidity, wind speed, or any heat stress within the crop. So we have put these sensors in such a way that in the field, this height of these sensors can be adjusted during the crop stage. And these all data sets we access remotely here. And this entire network is designed and developed by our team. And this data now, like Monday it is working, now we are getting data regularly. So along with these sensors, we have put a 3D depth camera. So that camera is real-time monitoring, and based on that we can estimate the crop growth so that we can validate the model simulation I showed earlier. So this is the data from, so here we can see that even it is like a very small parcel of like 0.7 acre within the field itself, there is a lot of variability in the temperature and heat stress and humidity. So this is like in Kutanad, we are developing a flood model, because the Kutanad, that in that region, the main challenge for the farmer is not irrigation or the water availability, is the water surplus, because most of the time the field is inundated. So his like their major concern is like how to like plan his sowing schedule, because many time like he's don't know like what time to receive. Normally they cannot follow the conventional season. So we come out with a model. So for developing this model, we have done an extensive field survey to collect the data. So across this the streams in the Kutanad region using a distometer. So based on our data, so we did a simulation. So this is the observed data is from the Central Water Commission, and so the model simulation shows the variability, and this is the famous 2017 flood. You can see that. So this is the simulated flood, and this is the paddy field where the farmer paddy field, these two dots, and you can see this is the Google map of corresponding Google map for that day. You can see the structure. So it is very like it's agreeing very well. So this simulation is done at 10-meter resolution. So here also our like ultimate objective is to come out a application like this for flood watch for the Kutanad region. So farmer can use this application for like planning their season, cropping season. Thank you. Question or any suggestion? Anything?
My only question is that
Please.
we should have a type of small library to check what kind of health is. I am asking this because I have
Ask madam, yeah.
So हमारे किसान को तो इतना पता नहीं है ना कि उसमें what fertilizer has to be put there. If they have to, mandatorily they will put urea.
Yes,
Without
exactly.
knowing that.
Exactly.
So that kind of awareness should be.
See, madam, I showed an advisory. We are like, for example, Kerala, the farmer we are sending in Malayalam. In Karnataka, we are sending in Kannada. In Tamil Nadu, we are sending that advisory in Tamil language.
Thank you. You would be sending that advisory to UP also now.
Yeah, like no, like
Yes,
that.
it
Yeah,
could be done.
yes.
Has to be done across whole.
No need to sit here. Still I need to sit here.
Thank you, Dr. Rakesh, for that informative and thought-provoking
So I
talk.
got some glimpse,
It's
right?
now my honor to invite our chief guest,
Are they
Professor
different
Vivekananda
ones?
Pai, Secretary General, Vijnana Bharati, to deliver the special address.
A good afternoon to all of you, respected Director 4PI, CSIR 4PI Institute, Dr. Imtiaz Parvez ji, Dr. Rakesh, Dr. Ashish, and all the researchers and students of 4PI and all the senior staff here. Actually, I had the occasion to come to this same institute in 2021, again connected to India International Science Festival, because that time, as part of IISF, we started a new event component called Science Through Games and Toys. So it was just an idea, and somebody, I think Pavitra from here was coordinating that, part of the team. There were others also, so it was a team, and how we can actually make this event happen. So that was the discussion, and for that we had come here. But now after 5 years, Science Through Games and Toys has matured a lot. IISF itself, as you know, already Imtiaz ji mentioned, it's a festival and it has lot of components. Like I will go through the different components now. But before that, I will also tell you how we started this IISF. Huh? Yeah, I have a presentation. I sent it to Radha ma'am yesterday. Yeah. In 2004, I think, our Kerala chapter, Swadeshi Science Movement. Actually, Vigyan Bharati has its origins in this city, Bangalore, at IISc, Indian Institute of Science, Bangalore. But one of our first units was in Kerala. And in Cochin, some of our people, what they did was, they compiled a set of quotations by Dr. APJ Abdul Kalam and brought out a small booklet. It was titled Footprints, very small one, and it was distributed among many students in that city. So our people were very enthused by the response, and they prepared a small report and sent it to Dr. Abdul Kalam himself. It was just like for our satisfaction. Nobody expected anything out of it. But surprisingly, Dr. Abdul Kalam himself wrote a letter back appreciating this activity. So that was a great inspiration. So in 2005, next year, what we did was, October 15th happens to be the birth anniversary of Dr. Abdul Kalam. So just now he introduced me about Swashraya Bharat National Self-Reliance Week celebrations. So what we did was, we had a week-long celebration starting with Abdul Kalam's birthday, which is October 15th, and we named it National Self-Reliance Week celebrations. So earlier also we used to have some science exhibitions and all. So what we did was, we had some seminars, some talks, an exhibition, and also we had an interaction of students with scientists. Actually, it is a very common thing today, but 20 years back it was not that common. And one of the first person who came for that program was Dr. Yashpal. I don't know, many of you youngsters may not have heard about him. I don't know, many have. But for my generation and all, his TV program called Turning Point, it was such a big catch. That was the way, in very simple terms, Professor Yashpal used to explain about science. So he came for that program, and he's an atheist. But his first remark on that stage was, there were thousands of students sitting there. So he said, "Oh my God." So coming from an atheist, it was very this thing. So that was one event. Then we had it every year, Swashraya Bharat. At some point, we started something called an NGO meet as part of Swashraya Bharat. Science and technology exhibition was always a component. Then we had student scientist interaction. At some point, we had industry institution interaction and seminars and all like that. In 2015, when Dr. Harshavardhan was the Science and Technology Minister, so we did it quite well in Cochin. So afterwards, something similar started in Bhopal and some other places also. I remember in 2007, we started something called Bharatiya Vigyan Sammelan. Dr. Abdul Kalam again came there. He always had this special relationship with... Okay, thank you.
This is next slide. This is for next slide. This is for...
Okay. He always had this very excellent relationship with students. So I remember in Bhopal, it was a huge pandal and there were barricades, and some senior people were sitting in the front, students at the back and all that. The moment Abdul Kalam came to the dais, all these students, they just crossed the barricade and there was no control. Like everyone was running towards him. Then he stood up and said, no, I will talk only after everyone takes up their chair. So there was a minister on the dais also. So the minister was thinking whether I should sit or not. But students started sitting and immediately Abdul Kalam said, "Aap bhi baithiye." And so that was the thing. And Harshavardhan, we suggested to him that we have this experience, and we always say CSIR has a huge network of labs. DRDO has around, I think, 52 labs. 42 CSIR? 37. DRDO also has around 52, I guess. Then DBT, DST, all these labs are there. So can we all come together and have something, an outreach program for science, which will be like catering to everyone, from students to research scholars to researchers to policy makers and like that. Because science is for the society. So it can be for the society when there is a communication between, as now he very well presented, the issues when it goes, your technology goes to the field. How the farmer can use it? You asked that question, right? How the farmer actually can make use of it. And so that part is very challenging, and IISF gives an opportunity where everyone comes together. There is a lot of communication between everyone. And today we are talking about multidisciplinary. So it is no more even interdisciplinary. It is very important that we understand different aspects of an issue, including social sciences actually, because what COVID taught us was that social sciences also play such an important role. So this can be a platform where everyone comes together, understands each other, and then takes away something which will be useful at a different this thing. There is a very famous speech by Steve Jobs. It is called Connecting the Dots. I think he delivered it at Stanford University Convocation. He mentions how, looking back into his life, so many events which were very isolated and not very relevant at that point of time, how they actually had a very long standing a implication, not just for him, but for a much larger segment of humanity. One example he is giving is that he was an adopted son, so he wanted to go to one of the Ivy League colleges. His parents were not very rich, but they didn't want to let his ambition go in vain. So I think they took a lot of loan and stress, financial stress, and started teaching him there. But he was not aware of all those things. But by the time he completed his first semester, he knew that this was having such an important burden. He is creating such a big burden on his parents. So he decided to drop off. So when he drops off, he had 1 or 2 months where he can do some courses. So he did a course on calligraphy. It was just for fun. It was not thinking about anything. Many of you who have used old type computers, when we are using those DOS commands and all that, it only used to have one font, that is Times New Roman, I guess. So it was such a boring thing. When he started making the Apple computers, because he was exposed to calligraphy, he had that knowledge. He started using different fonts for computers. And that is how different kinds of fonts started coming into computers. So just look at the implication of one person doing one course just to maybe spend his time, and the implication it has on the whole world. Actually, I think many of you might be knowing, even today Apple has such a huge, they show the their mobile and like the clarity and all that. Even earlier, like maybe in the 95, 97, Apple computers always used to be much more costly, for basically because graphics, people who are using graphics, they preferred Apple all the time. So graphics was their strong point. But the starting point was his course in calligraphy. Like that, he mentions many such incidents in that talk. If possible, you can Google and Connecting the Dots by Steve Jobs. And very inspiring talk. So like that, we had a program called Suraksha. He mentioned about it. We invited all the DRDO labs. I think around 26 labs came. But it was there, many of the DRDO people themselves knew that there is some biological lab of DRDO working on such and such a thing. There is a high altitude lab in Kashmir, Ladakh, which is working on another thing. There is another lab in Assam. They work on different kind of diseases and all those things. So many of them said it is an eye-opener for us itself. So a time has come today, we have to come out of our silos and look at much bigger context. The context is very important. And when we look at Indian science, actually, unfortunately, for a long time now, we have been out of context. One of the reasons what we think is the impact factor. Today there is this your system of impact factor, and where if there is a foreign publication, it carries much more weightage, and most of the publications today are not Indian. We just had, I was talking to Devika madam of Inflibnet. So they had taken down this thing, and I think in 23-24 around 2.25 lakh papers were published by Indians. Even some organizations, large organizations like ISRO, hundreds of papers on foreign journals, but maybe a handful on Indian journals. So it has an implication, various implications. We are actually in the process of assessing those implications. one of the implications is that our cities have one big problem: waste. It is a uniquely Indian problem, and it has Indian roots, in the sense that our food habits, our cultural habits, our civilizational, our civic habits, all these contribute to the kind of waste that we are having here. It will be different from Indian city to Indian city itself, and it will be much more different from Indian to the context to a Western city. So it may not be an issue so important that nature finds it important that it publishes a paper on waste, municipal solid waste, but it is something very connected to our being, no? So somebody recently gave a good example of a developed country, a society that solves its own problems by itself. That is a developed country. Unfortunately, I understand that you are all 4PI is doing a lot of work on data science. So look at our situation today. We are the biggest population in this country. We are generating probably one of the largest amounts of data. But how much of it can be utilized by us? I'm sure all of us are on WhatsApp. I'm sure all of us are using Google Maps. And all of us are on Facebook, on LinkedIn, everything. So much of data is created. But where is it hosted is one thing. But who is going to extract this? The saying is, data is the new oil. So when I discussed with you and you said that is the fourth paradigm, actually you are so critical for this country today. Because even there another issue is there. Like ISRO is generating so much of data. And the problem is how that data can be applied. I was asking Parvez ji, like that data you are doing data and data analytics, how much of it is being applied for urban planning? You are in Bangalore, and Bangalore is one of the cities where just covering 2 km or 3 km can take hours. So why can't we do it, like connect it with our transportation planning? I am an architect, so how I know how much data driven our urban planning is, or how much not data driven our urban planning is. So that is why 4PI is, I think you are at a critical juncture of this country, where if we have to actually achieve Vikasit Bharat, data and data science, data analytics and its applications is going to be very critical. And that is why when this IISF comes, we have our theme as Vigyan Se Samruddhi. I'll just mention one more quote, one more context, and then I will go into the programs and complete. It was in 1757 that the Britishers captured Bengal presidency. At that point, India's contribution to global GDP was upwards of 20%. Since common era 1 to 1750s or 1800s, India's contribution to global GDP varied from 20% to 30%. Just imagine 1/3 of the global GDP was by India. In 1947, when the Britishers left India, our contribution to global GDP was less than 3%. So from 20% to 3%. In his book, Era of Darkness, and even Jayashankar, our foreign minister, has mentioned, many have made this calculation or quoted this calculation, that the amount of loot that the Britishers took away from India in the 190 years from 1757 to 1947 In today's terms, it is costing around $45 trillion. US is the largest economy in the world today, we all know. And China is the second largest. The total size of the US GDP is 30 trillion and China is 19 trillion. So together that is 49 trillion, and what the Britishers took away from India is $45 trillion. And what was the method the Britishers used to extricate this wealth? That was science. How? In 1757 they captured the Bengal presidency. In 1767 they established the Survey of India. Then they established the Geological Survey of India, Botanical Survey of India, Zoological Survey of India, Archaeological Survey of India. See, this is all resource mapping completely. Then they started the railway line. We all say the Britishers brought railway to India. One of the first railway lines was in Kerala from Nilambur to Shornur. Why? Nilambur has some of the best teak plantations in the world, whole world. So the idea of this railway line was to take teak from there. Why teak? Because teak was used in those times to make ships. And teak was also used for railway sleepers. One of the best resources. So they used science, and there is a very beautiful book on colonial science by Deepak Kumar. I think Niskair published it probably, or Nistats. So he mentions about how Britishers first didn't allow Indians to do science. Then whenever they started allowing them, they started giving them lower level jobs, never allowed them to do higher ups. You have heard about Tata Steel. Earlier it was called Tisco. It was established, it is called Jamshedpur today. At that point it was called Sakshi, I think, in Bihar. Chota, it is not Chatana, Bihar. Yeah. How it came there? There was one person called Pramathnath Bose who was to become the geological survey of India. He prepared the first geological map of India and he was to become the head. He was the number 2. But his superior, the British person, when he want to retire, he didn't allow him to be the chief just because he was an Indian. And not only that, he said Indians cannot even walk in the field of science. How can we expect them to run? So he made a favor by not allowing an Indian to be the chief and his junior to be 15 years junior to be the chief. So Pramathnath Bose resigned, and the Mayurbhanj state, they asked him immediately to come and be their chief geologist. So he found that at this particular place in Bihar, there is a lot of iron deposit. He came to know that Jamshedji Tata was to establish a steel plant. He wrote to Tatas saying that if you establish your plant here for the foreseeable future, you will not have a dearth of iron ore. Tatas did their own surveys and they established it, and today it is Jamshedpur. So this was the kind of approach they allowed Indians to be in the field of science. And that is why this year when we say Vigyan Se Samriddhi, it is based on the experience of how science was able to used or misused to loot us, and today we have to depend on the same science and technology to take our country to a developed India, a Vikasit Bharat. So this event comes on 6th to 9th December at Panchkula in Haryana, and it is a celebration of science. The theme is Vigyan se Samriddhi, Atmanirbhar Bharat ki aur. And we had a national curtain raiser. Now we are having institutional curtain raisers, other programs also as part of this road show and state level inauguration, social media campaign. And I had an opportunity to go to IISF in Hyderabad. I was just talking to him. Like in 2004, we had the tsunami. So India wanted to have a tsunami warning system. And there we approached Japan, US, who had some of the best tsunami warning systems. But either they denied or they were asking for the moon. So at that point, the MOES secretary, Shailesh Naik, he just scouted and called a few people and asked, what are the components of a tsunami warning system? So there is remote sensing, there are sonar, this thing, sensors in the ocean, then there is communication, different components. And we have different institutions, each is capable of these components. So just like that saying goes, Ayogya anartham aksharam nasti nasti moolam anaushadam ayogya purusho nasti yojagas tatra durlabha, means there is no single syllable which doesn't have a meaning. Nasti moolam anaushadam, there are different plants. There is no root which is not medicinal, but people who know the property are not there. And ayogya purusho nasti, there is no person without any capability. Some capability every person has. Yojagas tatra durlabha, he who can bring them together is the most difficult person to get. So Shailesh and I called up these people and we made our own tsunami warning system. I had the opportunity to go and visit that. So it is in IISF. They have combined all these things and now we have one of the best tsunami warning systems in the world. But then I had the second opportunity to go there. And at that point of time, they had improved on it with a huge screen. The whole world we can see. And anywhere, any point there is an earthquake or there is a cyclone or there is a low depression, it comes there. They have all the modelings. So based on particular thing, based on the models they have created, they define what are going to the implications. That is why recently we had the cyclone Monda, and we could actually define where it is going to touch the land and at what time and with what intensity. So we take all the precautions. So you might be remembering 20 years back, 30 years back, one cyclone and 10,000, 15,000 people were getting killed. Today it is just in the handfuls, because they also, not because they were not warned, some people just ignore the warnings. That is why they are losing lives. So that is the kind of change that India has happened. Then there is a moon there. It is not a moon, it's a sphere on which there is this whole globe is projected, and different parameters we can graphically see. It is an amazing thing, and that is going to be brought because MOES, it's an MOES institution, and Ravichandran, they wanted it. So it will be displayed there as Science on Sphere. Then just like in this video that we had shown, the spacecraft is going. India is now creating this Matsya 6000. It is going to be India's like underwater thing, which will go deep up to 6 kilometers. Actually, I had an opportunity to go to NIOT also and see the earlier one of this. This will be in platinum, the 6 kilometer one. But initially they did one in steel, and that will go up to 500 meters. Actually, it has already gone, I guess. So there will be a model of that. So these are two very interesting things, because in Guwahati we had brought the moon, and Somnath sir also had come, and it was a huge hit. So that is why we are bringing this one this time. Then because it is in the Himalayas, we have some programs on the science with northwest. Last year it was in northeast. So we are having different programs for the Himalayas and the northwest. Then India has actually Indian Ocean Rim countries. India has created a grouping. 28 countries are there. So there will be a discussion from representatives of the Indian Ocean Rim countries. Then fostering partnership between Indian Ocean rim nations through science diplomacy, promoting knowledge exchange, building innovation partnerships. This will be on Indian Ocean rim countries science diplomacy. Then we have science olympiads. Vijnan Bharati also has a program called Vidyarthi Vigyan Manthan. So winners of that will be having a special program. This is a new event this time. And another one on waste to wealth. Then transformation through new age technologies. Actually, this is something where 4PI can also contribute a lot, because it will be on AI, ML, robotics and all that, data science. We have student scientist interaction programs, then innovation, entrepreneurship, then nuclear energy for self-reliant India. One program is there to actually popularize the importance of nuclear energy. Ideas for Vikasit Bharat and SNT hackathon. This also started with our Chandrayaan, we can say, because it was on Chandrayaan landed, and at that point of time Modi ji was in Paris. Then he came back first to Bangalore and addressed the scientists of ISRO. Then he suggested to them that you can have a hackathon for space technology, space program for ease of governance. Then we called up ISRO people and asked why IISF is the best platform, because all the science ministries are there and we are also there as an outreach. So can we do that? And Somnath sir suggested the topic at that year that Bhuvan portal can be the thing, because as I said, we all use Google Maps. Bhuvan has a huge database, but it is not being used basically because the user interface, it is basically based on apps which are basically third party creations, and Google Maps has so many third party apps, but Bhuvan lacks it. So he wanted to give that popularity, and within a span of 2 months we actually got 4,000 teams and 10,000 students, and but we could accommodate only in the final, that was the initial phase ideas. Final phase we could accommodate only 200 students, and out of which 81 had been absorbed into as interns in ISRO, because they were all very good students. So now it has become an annual event, hackathon. Last year it was also there. Now it has become, all the science ministries give their problem statements, and based on that this hackathon is happening. Then young scientist conclave, where young researchers, they present their papers. Thought Minister, Secretary, Council, CEO conclave, and Vision Samsad. This is also a policy discussion. Aspiring, this is a science teachers meet where we showcase to them how experiential learning can be imparted to students in science education. And Global SNT Alliance. These are different events. There is a science literature festival, a media conclave, national social organizations meet, and science through games and adventures. This was one I mentioned in 2021. So these are different components of the India International Science Festival this year, and hope to meet you all at Panchkula. Thank you. Namaste.
Thank you very much, sir, for your inspiring words and for gracing this occasion with your presence. I now request our respected director, Dr. Gopala Krishna Patra, to deliver the presidential remarks.
Yeah, good afternoon. I think now everybody is aware of what is going to be there in IISF. I have been invited for the Vision Sansad, so I will be there on 8th to attend the Vision Sansad. So basically, I think that's a discussion about the thing, so I will be there for that. Though we have a parallel conference here also, being that is the Supercomputing India. In a similar time scale, so there is an overlap between those two, so we'll have to manage the both together. So I will be there on 8th, and if you are there I will certainly
I'll be there at Mission Samsad.
Great. So we'll meet you there. And as far as science is concerned, I think India does lots of science, but then we don't normally advertise it. We just publish papers which only some elite group reads those papers. We don't bother much about that, because as he said, like the impact, like because I need to always look at my promotion is there, so I need to publish 10 papers. I go ahead and publish, and after that I'm never bothered about whether it is useful to society or not. I think IISF is a place where these things are taken care of. So you are going to the common people, not only a elite group of people who are interested in science. They are all common people who also will be showing interest in that. In fact, I think whether it is first or second, we had attended, me and Anil had attended, it was first one. And then we both of us got a best poster award there in that event. I think that is still here, that award is still here. So we remember the India International Science Festival. It was a quite big event even at that time. So that's something which is great, because getting all the institutions to come together and then making them is not an easy job. Somebody was asking whether NPL. No, I think NPL was second one. IT Delhi was first one. So it's okay, one of that. That is what I remember. No, the thing is, like somebody was asking, why don't we organize such event? I said it's impossible we don't have the bandwidth to organize such events, which is like too huge. It's a festival. It is named as festival. You can really see that it's a festival. It is not actually a exhibition, or it is not like science event or something. It's such a big thing. I had thought about talking about 4PI, but then we discussed it, so I will not touch upon that. But what I wanted to see is, like you talked about the Northwest Himalayas. Okay, so Northwest Himalayas, I think we have already conquered quite a bit the Northwest Himalayas. Dr. Parvez is here. We do lots of studies on Northwest Himalayas. We have observation stations there. I think we have different types of observation, GNSS observation, then ground motion, broadband observations. Now also we have a big project, mission project. We are part of the mission project of CSIR, where we are going to look at all the geohazard related issues in the Northwest Himalayas. So we are already in the Northwest, this one. Northwest. So that's something which we are already working. So when you talked about the Northwest Himalayas, I was collecting that, yes, we are going to work in those areas. Of course, we do lots of mission projects, lots of things for society. One of that you just heard from Dr. Rakesh about how how technology can influence the agricultural sectors with precision agriculture and all. And also we have projects which are driven, typically an AIML driven projects. Like AIML is now used in all our projects. Even what I talked about, geohazard also will have AIML, the agri-tech has AIML, but there also we need to look at developing new AIML tools and techniques. So there is a project which we are coordinating called CLAIM. There we are developing AIML techniques for industry. So you can we are looking at society in one hand, we are also looking at industry as one hand. So that's our focus. Whatever we do now, it should be useful to somebody, whether it is society or whether it is going to be the industry. And the other thing that we are looking at, whether our research is kind of supporting to strategic sectors. For example, the morning we discussed with Anil about the cyber security, which is again like a strategic sector which we are contributing. We are also right now discussing with ADA, DRDO, working on some of their requirements where AIML is going to be useful. We are also discussing with the ISRO for multiple other activities. And it's very important that we attend such events like IISF and other things where we meet multiple peoples. Like today morning, Neha came to me and saying that she attended one ISRO conclave in Delhi. She came now, she says, I wanted to interact with so and so scientist who is working in the similar area of mine. So this kind of events or the festivals that we are talking about, it helps us in creating those collaborative ideas. And I will tell you, I think individually developing science period is already over. Now we cannot do that. It has to be collaborative. In fact, I was talking to some of my colleagues. One of my friend who is a professor in IISc, he's an aerospace engineer. He's a controls person. Now he called me saying that we have started a startup. We are inaugurating a tool for diabetes insulin pump. I said, why are you doing that? You are an aerospace engineer. You are to basically design aircrafts and then provide the control for that. He says, no. The what they have developed there is exactly the same control system that they use in the aircraft. Because insulin is such a important factor for diabetes people, where the insulin doesn't get generated automatically. You will have to give insulin at appropriate value. If you give more is a problem, if you give less is a problem. And if you make it manual process to give the insulin, certainly you will do that mistake. You will not be able to be accurate. So how do you do that insulin given as an automated process is similar to the way aircraft also controls its system. So he says, in fact, he was joking saying that in aircraft it's much more tougher because you need to work at a millisecond and other time scale. But for health, you actually have sufficient time, maybe 10 minutes time scale is what you are looking at. So it's much easier to work in healthcare for the same concept of control system and then work here. So this cross kind of development, one concept from one thing coming to another thing, I think those things can happen only if we meet in such events where we meet to multiple different set of people and then work towards them. The other thing you talked about, some indigenization, like for example, we publish papers in only external journals and other things we don't publish because the viewership is much lesser for Indian journals. The thing is like we have a project called Cohort. Okay. Now, what is the purpose of Cohort? The purpose of Cohort is, right now when we go to our check our blood, we give blood sample for various tests, correct? Now they say hemoglobin, this is your value, this is the range. Who defined those ranges? Those ranges are defined by French people, because they only did a cohort maybe in some 1900 something, and they defined a range saying that the value of hemoglobin has to be between this to this. But that may not be correct for Indian population. So the main purpose of this cohort, which is called a CSIR cohort, is to collect enough data from across CSIR. See, the beauty of CSIR is it's a mini India. You have people from every part of the country in every place. So you collect data and then define the required parameters for India. So that is one thing which is going, but it's not an easy job to do because you need to collect over periods. So right now the current project is for 5 years, but then even 5-year data will not be sufficient to precisely tell what should be the value for Indians. So that there is some work going on. So lots of like what you talked about, lots of things we are already working on, and then we will be working towards that. So thank you very much. You gave a very good view of the IISF. Of course, before that you talked about the science and then how things have gone, connecting to different stories and other things. So thank you very much. And I think IISF, I don't know whether it is not that everybody can go. Maybe we have to find out who can go and all. But I think it will be live telecast. There will be some events which will have some live telecast. I think people should watch them and then see them. So I don't know if it comes to Bangalore sometime, maybe large number of people can go. So thank you very much.
Thank you, sir. To express gratitude on behalf of the Institute, I invite Dr. Ashish, Principal Scientist, for the vote of thanks.
Good evening, everyone. So, good evening to honorable dignitaries on the dais, my colleagues, and everyone who has gathered here for this event. So it's my privilege to propose a vote of thanks on behalf of my institute and acknowledge the contribution who has made this event possible. So, and ISF is really close to my heart. I have opportunity to be there, I think 2 occasions, and not as a participant but as an organizer.
So once last year we organized Pragya Bharat event. I was part of the team, and that event was live, late telecast. So first and foremost, on behalf of my institute, I want to extend my hearty thanks to our chief guest, Sri Vivekanand Pai, who has spared time and come to our institute second time and grace this occasion. We had wonderful opportunity to hear your thought on science, general science and our history of science in India, as well as the overview of IISF 2025. So thank you very much, sir. And now I request our head to present a memento to our chief guest. Thank you, sir, again. Thank you. And now I wish to thank our institute director, Dr. G.K. Patra, for his kind support and advice for all the event preparation here. Thank you, sir. Thank you. Now my special thanks to Dr. Rakesh to showcase the technology of national interest based on interdisciplinary research and solving the real challenge for the nation. So thank you. And now I extend my thanks to Dr. Parvez, head TMD, and his team, who has been coordinating and organizing this event very precisely and executed nicely. Thank you, sir, and their team also. And now I extend my thanks to our administration, purchase and finance division for providing their support, full support for this event. Thank you. And last but not the least, I want to thank to CSIR 4PI team for each and everyone for their support who has come and make this event successful and memorable. Thank you.
Thank you, Dr. Ashish. I request everyone to please stand for the national anthem. All are invited to the tea.
It's not the normal cycle.